Happy Bow Tie Friday. I'm Austin Griffith. I'm here with the Build Guild. We're building with the Build Guild. We're guild building. I think first up, we're here to show off just like what we're working on with Scaffold-Eth, Scaffold-Eth 2, what we're building. First up is Codechef. Codechef, if you want to take us away, share your screen and show us what you're working on.
Okay. And I'll share my screen. Can you see my screen?
Looks good. We got it.
Let's see now. I'll give you 1 minute. Okay, hi everyone. So I built a simple game. It's called the Chijoke Navigator, where you drag the eggs to their hopefully the correct nest. So guess the eggs got mixed up, and now you need to help the chicken find their nest of their owners. So yeah, so I like a simple drag and drop, so you can drag to one of these nests. Hopefully it's correct. Yeah, I like a simple drag and drop. Still trying to fit the animation, but kind of works. And then you will pay 0.1 ETH and to hatch. Unfortunately, we did not get the less. So I use like random numbers on the smart contract, and very simple. Yeah, that's what I have so far.
Not a single one was right. What the heck? Dang it.
Oh yeah. For some reason I made the game. It's kind of like vague. So it wasn't good to news. I'm sort of trying to fix that, but I ran out of time.
So technically, does it like, is it already revealed? Like how do you do the randomness?
Oh, when you click on the hatch, I just call some random number. So I will grab the user's position of the egg, and then just do, and then I will generate the winning, I guess the winning position or the winning number using a random number, and then I just compare it, and if you match all, then you win the game. Yeah, still working on it, but I ran out of time.
So basically, they pick their order of the eggs that gets submitted, and then on basically, it looks like the block timestamp is catch hashed, and that's what you use for your randomness to decide what the actual order is. Is that right?
Yeah.
Cool.
Not the correct way, but I ran out of time.
And if you take on the dice challenge on Speedrun Ethereum, you can figure out how to build an attacker contract for something like this that uses block hash. But this is an awesome game and awesome. I love the creativity with the eggs and the chickens. That was awesome. That's a fun way to make a game out of it. I think Damu and Carlos, like Zach, we're all talking about trying to figure out how to make a game. And I think it really takes this kind of playful creativity that really makes it happen. So keep doing this, keep building. Cool Scaffold-Eth too.
Thank you.
I think Casey Pele is up next. I think we hear you, but I don't hear you. Oh.
What about now?
Yeah, we got you.
Okay. Hi guys. Good morning, afternoon, evening. So actually, what I've been working on, I and Daniel spoke about I think just a card game. So he showed me one which I kind of prototype and would be making use of the socks NFTs. Like I don't know if you could remember that socks NFTs they did before. Yeah, so that is, let me share my screen. So it's just a little game. So just notify me the moment you start seeing my screen. Okay. So
I see it.
okay. So this is the game, just something little. So I'll just go straight ahead. I'm creating the game So here you just put in the level which you want. It's just something simple, still working on it. So yep, and here we go. And yep, yeah. So boom. So this is it. So you get to create a game, then I can share you the link and you get to join here. But because I've been testing on it, so it automatically I think joined the second player. So I'll be playing using this address and this address at both players. So as you can see, it's my turn. It's just a card game on the blockchain. So but the cards are NFTs. So this is how we play them. You select two socks. If they don't match, they close back. Then your opponent get to select two other socks. They don't match, goes back. So this is how you keep just playing, and you can actually, I made use of WebSockets here to just create, simulate kind of mini chat between both players. So you can just get to select socks, does not match. Um, so that's it, just something simple, and get to play with friends, and
So
there's no
this is very fun. I love the troll box too. You got to have a troll box for a good online game. What's the randomness here? Like, how do you pick out or shuffle these? How could the
okay.
player cheat, I guess?
Okay, for the randomness, I'll be integrating chain link VRF.
So
That's
like it rolls, and it's almost like you need like a random every time someone flips one over or something. Like I don't even
no,
know how you would do, or like maybe it's like zero knowledge or something where you have to like flip them over to discover what's there, and then it flips back. I don't know. It's like a memory game doesn't really work because you want to like you would keep a persistent state, but
yeah,
the playfulness of it, the flipping the cards, the like maybe not every game we need to make needs to go on a blockchain and be, maybe this could just be for fun for kids. It's fun. I'd play with it. There we go. We got a winner.
yes,
There's a match. What happens now?
yep. So
Oh,
yeah, so you get to select your opponent. You get to find a match all through. Let's just get something. No match. Find something here. I guess it should be this. Nope. One
so each
more.
one of these are transactions. Like each time you flip, that's a transaction on the.
Yeah, no, that's for both. When a user selects one, the second one, then it creates a transaction on the blockchain to check if it's matched.
Got it.
So,
Cool.
yeah, so you don't just, yeah, so that's just basic functionality. I don't know why I'm not getting this. I'm supposed to have, oh, wow. Yep, and I think this should be here. Nope. So this sucks. It's kind of, yeah, no,
Okay. There he was, right? Oh,
yeah.
oh.
So let me just cheat. Let me just cheat. Um,
Well, I mean,
so
we saw it happen. We got it. We got it.
yeah, so that's just it about the game. Just something simple. You play with someone and get to chat live, and that's all.
Cool.
You get some incentive for winning the game. So at the end of every game, you get to reset the game. Then on the smart contract, it shuffles the card. So when you reset the game, this is it. So in order to have like different card positioning, so when after at the end of the game, you get to call this function the reset game, which actually reshuffles the card. That's the NFTs. Then this is the function that generates the random number, which would actually be using chain link for that. For now, it's just kind of block and some other stuff we actually use. So, but for this, we'll be using chain link, and you just get to shuffle the NFTs then you get to play again. Or you might decide to cancel the game or end the game. And this is the function that actually handles the move. So you get the idea of the game, then the card, that's the first card, and the second card a user selects. That's this, both of them. The moment it gets selected, this is the function that is being called. So this is where we do all the matching. So I had to check here. If they are both, if they are same, it turns the card to here. This is match, which is true. Then listing for the event to update the front end. Then I think that's pretty much it for the game. Still adding other functionalities to make it kind of huge and
Cool, man.
a little
Cool
bit
build.
difficult. So we also work with levels. Yes, sir. So also work with levels. You could increase the level, either take the cards to 16 or 32, just based on the levels. So you can get to play harder stages on the game when creating the games. So this is where is it? Create game. Yep, and here. So this is so that's just it about the game. Just something simple and just for you to have fun.
Cool. Cool build, man. That's a fun one. Yeah, I don't think we want it any harder. We're only able to find one match. Okay. Next up is Solid Oracle. Solid Oracle's I think he's got a vault, continuation of the vault. Maybe this one's leveraged up. We'll see what he's got. Solid Oracle, if you're out there.
Yes. Hi, everyone. Can you hear me and see my screen?
Yes.
I can hear you. I'm waiting on the screen.
Oh, yep.
Got it.
Okay. Yeah, that's right. So last couple weeks ago, I presented the Solid Vault, which was basically an ERC for 626 vault that deposited Gorl Ether on Aave, and there were all the tests there. And I wanted to add a second, let's say, second level to this, and I call this one levered vault, which takes the usual structure of inheriting the ERC 4626 vault. So we have all the logic there. But there's a couple of big changes. First of all, after we deposit the funds, if we have leverage staking on, we are actually borrowing on Aave, and the borrowed funds are then supplied again into the Aave to earn yield. So basically, if we deposit 100, in this case it's Matic, 100 Matic, you can set a percentage like 25 Matic that you get out of the loan and you deposit again. So you basically have deposited on Aave earning yield 125 Matic. So we had to get have some getters as well to get the pool data of the loans, the price feed of Matic, and also a big change was with total assets, because when we want to withdraw from Aave, we need to have a fresh net asset value from the Aave pool. We need to know exactly how much equity and how much debt we have in Aave in order to factor that in our calculations to withdraw the right amount, which is not, obviously we have to first pay back our loan plus any interest, and I'll talk more on that in a minute, and then we withdraw our funds. So interesting logic on how to deal with leverage inside a protocol like Aave. Another addition was the harvest function, where that was again, here we have 125 Matic on staking, but the harvest needs to be calculated only on our equity value. So we need to basically do some calculations in order for correctly accounting the total profit accrued. And so again, a key component of the harvest function is again this total asset function that was changed with respect to my previous vault. And then I did a lot of tests to make sure that what I told you makes economic sense. And so, yeah, if somebody's interested, you can go through them. And we test leverage with withdraw. We test leverage deposit, and we also, do withdraw a fraction and make sure that that fraction also corresponds to, giving back a fraction of the debt that we have in place. We have also the harvesting, and so this was an add-on build to my previous one. The front end would stay exactly the same because we're always depositing in the same interface, but then we're building that. We're building yield on top of this. One TLDR is that I discovered with these tests that after a year, the loan costs 5% on Aave, and instead the yield I was getting is 2%. So actually, every loan, every Matic I was pulling out as a loan, what was actually costing me money. So if somebody's thinking about doing these kind of operation, this could be a good framework to test with forking mainnet without risking any money, if it actually is profitable. Because honestly, it was a shock for me. So yeah.
Great build, man. Someone, I think McTody said big brain stuff in the chat, and I agree. This is cool stuff. Getting into these vaults and how to harvest and what the strategies are. Like this is cool stuff. It's big brain enough that I probably wouldn't YOLO more than $100 into this.
And another point is I also used a lot of this cheat
I
code
saw that.
wrap even after every test, because I think Aave in the more mainnet fork needs a bit of time to deposit, withdraw. You can't just do too many things at once, and so I made sure that all the tests actually work with a decent time delay.
Cool. That's neat stuff. Are you going to deploy it live? What are your next steps, or what are you thinking you want to learn next or do next with this?
I'm working currently on a basically I want to have a token that grows over time in value, similar to stablecoin, but without being pegged, and getting it backed by a yield generating vault. So I have a token, an interest bearing token that is in the front end, but so that the user can deposit and withdraw and have that logic pretty clearly and fast. But then back all this logic by actual DeFi protocols like this one. And so, yeah, it's a lot of things that need to come together. I look forward to presenting that once it's done.
Awesome, dude. Yeah, keep building. These are great to see. It's
Awesome.
Scary thinking about YOLOing into these though, but it's really interesting.
Yeah, these provide a good framework to test these big protocols that can become expensive if you're not careful, because you think, oh, I'm getting leverage, but then the yield you're earning is actually lower than how much the leverage is costing you.
Right. Yeah.
Leverage is not written anywhere, unfortunately, because the leverage is compounding over time as well, the interest rate. And so we are doing these tests, this forking, and I have all the the contracts here, and the make file is all set up for forking mainnet. Is really valuable also for me that wants to build DeFi protocols and want to make sure that users get the yield that they're promised.
it's probably hard to test even when you fork mainnet. What you don't have is the army of like arbitrage bots continuing to keep things moving. So once you fork, it kind of like the rest of the network freezes and you kind of do your thing. But if you go trade on a DEX, like now that DEX is actually off from the price, and an arbitrage bot's not going to come back in and clean that up for you. I wonder, I see this idea of this kind of like test environment where you have lots of bots running and you can kind of play with these things in like a real-time sense. But I don't know, does that sound like something that would be helpful for something like being able, or do you find that it doesn't matter that those arbitrage bots aren't running? You're able to run the tests you want to run and things work out the right way?
So bots are an issue when they are able to front run you or do transactions on your behalf. Since we're interacting here with a protocol where you deposit funds, obviously they could front run you and deposit funds before you, which that is always the case, but protocols like Aave tend to have, pretty big liquidity. So yeah, you could get in a bit later, you could get a lower interest rate, but yeah, I think yeah, that would be, I think it would be difficult to simulate
True.
exactly how bots operate.
Okay, cool. Awesome. Thank you, Solid Oracle. Another solid build. Keep building, keep expanding your repertoire. I think Irfan is up next. Go ahead and take it away. Sorry if I didn't say your name right.
It's completely fine. I've actually built after completing the challenges, I've actually built the first thing that I could think of, and of course inspired by Austin's classes. Can you see my screen?
Yep, we've
now?
got it. Yep. Weighted multisig.
Yes. So this is like this is not rocket science. It's a very actually simple build. The multisig was, as far as I'm concerned, one of the challenges previously, and I just wanted to merge it with another idea. And I said, why not ERC20 tokens? And I just used the ERC20 tokens. I mean, this is the Sepolia deployment. I was just like, why am I not using the ERC20s to represent the voting weight, just like how DAOs use their governance tokens to represent the voting weight? So I just did something similar, but being different than the DAOs, of course, I cannot really leverage the allowance functionality of ERC20s here, because the multisig contract doesn't really take any ERC20 tokens from you. It just looks at your balance to determine your weight. And yeah, there were some rules specified by Austin, I think, in the explanation of the challenge. And one of them was like making BuidlGuidl one of the executors and giving them this much of like 33% of the voting weight. And once you have the voting weight, like once you have some ERC20 tokens, you got them from Austin, you got them from me or from a DEX, you can come here and use that voting power to actually have an influence on the decisions that are going to be made. Let's call it that. Now, actually, you can create a proposal to this multi-signature wallet by calculating a custom call data. Well, I didn't embed a call data calculator here in this front end, but if you calculate it outside, you can actually create a proposal call here. And this call is going to be delegated by the multi-signature wallet to your destination. And there are also some configurable variables like the weighting threshold. Right now it's set to 666. This means 2/3. And for example, me alone, I can pass, I don't know what it's called. I can make a decision basically alone because I own like this and this and this. So they add up to 6666. So I can barely execute like a call. And yeah, I think the lots of the things to talk about are just front end things like, see, this is as I told you, this is the custom call data proposal screen, but you can also use these things that I embedded while experimenting with the front end to create a new proposal as well. So let's propose a new weight threshold here, for example. It's going to populate this room. You can hit create and you can just sign it and stuff. And yeah, it should be seen here. And then it will require people to sign it. Now, this pool is, of course, sent to a backend. So it's like a state channel. It was already built in the challenge itself. So I didn't really mess up with it. But then we also have a role of executors, and you can propose new executors from here or propose removal of them and stuff. And they're the sole ones that can execute an offering. Guys, this build is really about this one, but I have one other build that I would like to share with you as well. And now that the first two builds were about randomization, maybe I can share my other build as well. But first of all, I would like to, if you have any questions, we can discuss on this one, or do you have any comments to add? Can I move on to the next build? What do you say?
My first question was going to be, hey, that's Scaffold-Eth 2 back there. Are you using Scaffold-Eth 2 to interact with Scaffold-Eth 1 up here? That's the first time I've seen someone do that, but actually these are two separate projects. You've got something in the back. So yeah, first of all, I think this is a really neat build. This is a fun kind of twist on a multisig. I think that one thing that you're not leaning into here is that now that you have this ERC20, it's composable with this whole other ecosystem of things that let you use this ERC20 for different things, right? You could, put it into the compound governor, or do, a Merkle drop of the ERC20 to people. You have tons of other tools that now you can use, but also that's also scary. Like, people could buy, this could be sitting on Uniswap and you could buy votes, right? Like, you could just go buy some of the token. Like, you could calculate the price, the 666, right? Like, what is that in USD, right? Like, what does this vote cost to go buy? And that's kind of an interesting, I don't know, it's just an interesting experiment. So that's my notes on this. Great build on the multisig. And if you have a second one to show off, definitely go. Yeah, if there's other questions, please.
Maybe I can say, I can add something. Maybe it can be done with maybe soulbound tokens for weighted parts. Maybe for some challenges, for some such sessions, people can get their soulbound tokens, and thanks to them, they can get their weights and increase their weights for the voting power, maybe.
Are you suggesting that if I'm utilizing POAPs, I'm able to increase the voting power of people? I didn't get that part. So.
Yeah, maybe just another idea. For maybe instead of, like Austin said, maybe buying USD for getting voting power, maybe they can just earn POAPs or maybe soulbound tokens, NFTs for some specific cases. Maybe they can earn their voting power thanks to these. In addition to ERC tokens. Yeah. But it's very built.
You can build many different dynamics over how you're able to distribute, how you're actually distributing this weight. You can make it earnable, you can make it soulbound, you can make it ERC20, and it would definitely be another good build.
It could be. I thought when he was saying soulbound, he was saying soulbound like the ERC20 doesn't transfer. So keeping it as an ERC20, but disabling the ability to transfer it, but then having some mechanism of like minting, where there's like always some kind of inflation to the whole governance, and hopefully that's somehow trickling to people who like care about making the right decisions. But I think just playing around with all of this stuff is what we're here to do, and Scaffold-Eth lets us do that. Okay, go ahead on to the next build. It looks like we got a Scaffold-Eth 2 build and randomness, I think you said.
Yes, exactly. I was really wondering I was wondering why there isn't, maybe there is, I don't know, but why there isn't a big gambling platform built on Ethereum where multiple users can
Isn't that what it is? That's what people say it is. It's just people gambling.
Yeah, I mean, it's itself is gambling, right? So I was like, I saw this commit reveal scheme video of yours where you introduce a rock, paper, scissors game. And then like later on, I understood why you pick like a game that includes two parties only, because like when it's two parties, there's economical incentive. Like when the money that you're going to win is less than money that you're bidding, then it's mathematically safe way of gambling with somebody else. Well, but to be able to discover this fact in the first place, I actually had to build this thing. And it might look silly, it might not be very advanced, but let me also take you through this presentation. So maybe I can hear your ideas and ask you some questions and stuff. See, this is just a gambling application where I try to simulate a room-based game, room-based gambling game, where people can participate. And participation in this sense means a cryptographic commitment. So everybody, when creating a room or joining to a room, you're supposed to make a cryptographic commitment containing a random number and your address. Now, in the game, like the rock, paper, scissors game, the user actually makes a decision. But here I'm creating a random number. So it's more like a gambling. So user decision doesn't really matter much. You could definitely gamify further this, like you can make the user make a decision, maybe among some card decks, maybe they can pick a number, but at the end of the day, you're going to introduce randomness using the participants' browsers, JavaScript. So their decisions don't really matter much. So yeah, how should I proceed? Yeah, let's create a room together then. It's a cryptographic commitment containing your address also, because if it doesn't contain your address as well, I can easily replay your commitments and come up with the same random number as you did. And yeah, so is this hard hat? Does it work? Sorry to consume your times, but let's create a new room of 0.3 Ethereums, right? A capacity of 4. Now this capacity is the room capacity, and I'm not starting the game. This is just the dynamic that I introduced. You know, I needed to make a decision and I did it this way. If the room capacity is not fulfilled, the room creator can abolish the room, but when it's fulfilled, when 4 people joined, they cannot abolish. The game has started. So when you create a room, it's listed here, and the others should be able to see it. And what the hell? This is an unexpected error. Maybe it's because it's mixed up with the other game that I did. And then, yeah, let's refresh.
Is that a transaction to create the room? Is that happening?
Exactly.
Okay, cool.
Exactly.
All of that's happening on chain. Cool.
So yeah, so it should be listed. Actually, it loads live, but I'm not really sure why it's not happening right now. Maybe I didn't join from one of the... Yeah, there it is. Again, the same problem. So the live rooms do get listed down here, and they're bound to Ethereum events. Sometimes I'm having problems with loading the events. I don't know why these kinds of things keep occurring, but sorry, I'll be consuming a little bit more time from you guys. So this is the room that we created. We set the room fee to 0.3 with 4 participants. That adds up to 1.2 Ether. This is the big price. So I will be distributing this price to 1 person only. I'll be just granting, but more dynamics can be introduced here. You can, for example, determine 3 winners, and you may determine like full entrances or half entrances, quarter entrances, and come up with a mathematics to collect and distribute the reward. But I realized while building this thing that you need to build all your gamification on top of the commit reveal scheme and its own limitations. So and I will also show you something interesting as well about having the half of the signature weight that we talked about in the beginning. But first, let's start to reveal some random numbers. So this is the room creator. Here you can see the random number. You can also take this from the user as well. Like you can make this a user decision. Let's start revealing, and it's also going to be a transaction. So as we keep revealing, you will see the XOR display getting updated. Now I put the XOR display here because, well, XOR is just one way of creating randomness over the random numbers that you collected from different parties. As far as I'm concerned, there are like different methods, but XOR is a very popular one. And the XOR accumulator starts from 0. And just to be more scalable, I am aggregating the XOR value as people keep revealing their random numbers. So this is just to emphasize that when you reveal in a commit reveal scheme, when you reveal your random number, it's going to be available to everybody. People will be able to see it. And if they're able to see it and XOR doesn't have no ordering, so they can actually simulate who's going to be the winner if the room ends in this setup, right? So room cannot end this setup because there are 2 more pending reveals. But there's also one more nuance. What if a user does not reveal at all? So we need a mechanism to prevent this. So either you have a very big lottery application with a lot of participants, and you don't really worry about what if people don't reveal. So when people don't reveal, you just forfeit their tickets. But here, a room-based game where there's a group of active participants waiting for things to be resolved, you cannot really let this happen. So I introduced another mechanics to abolish the room. So there's this, there's a period like 3 minutes. I set it to 3 minutes, but you can set it to anything, which should be carefully considered. Whenever somebody makes a reveal, it sets a new time span, a reveal expiry. And if nobody makes a reveal inside this period, then anybody can determine, like, abolish the room. They can finish the room with the current status. So this guy would get paid. And how to do that? You can actually, if you refresh the room after that period, there should be a button like this, finish game. Well, it's not over yet. Maybe that's why. This was the first thing that I would like to say. And the second thing is, at this point, this guy is the winner. He's one of the valid revealers. So let's check who he is. This one. Right now, this guy knows they're the winner. So what they can do is they can go up to people that didn't reveal their messages yet, and they can bribe. Like, they can say, hey, I'm winning 1.2 Ethereum right now. I can split it. We can split it among us 3, because there are 2 pending reveals. They can split this money. They got in for 0.3 and they get out with 0.4. So it's the other revealing guy who just got scammed, you know. So this really eventually made me realize that, well, yeah, I can implement like room-based games like this, gambling games like this, but now that we don't have like on-chain identity verification, we cannot really detect, like, I cannot really detect if Austin is playing this game with 100 accounts, because he can generate a room with capacity 100, and he can populate it with his own accounts so that he knows about all the source of randomness. So he gets the control, so he can wait for praise to come in. So yeah, this was the idea that I explored, and I tried to explain this in a nice manner in the README as well. So yeah, hope you liked it. Let's keep revealing as you ask your questions and make your comments. What do you guys say?
One question in chat was, what actually makes you the winner? Like, what's your metric for deciding which one of the players wins depending on their random number and the result?
So after the commit reveal, we end up with a random number, and you can determine your own way of determining the winner, as I said. But what I do, what Halal Gamble does, is I take a modulo operation over the valid revealers, not the invalid revealers, because I want to punish them. I want to punish invalid reveals. Upon the valid reveals, so it's like 3. If it ends with 3 valid reveals, I will just take modulo of this number over 3, and then determine an index and pick that revealer as the winner.
Cool. Got it. And another thing, I think McTody commented, or McTody and Damu came to the conclusion that you also want to throw a salt in with your, even though you have the address and your reveal, I don't know, maybe the address and your commit, you also maybe want to salt it. I don't know, so something to add a little bit more entropy, so someone couldn't off-chain be brute forcing, looking for your, if it was just rock, paper, scissors, and you just hashed your address and your move, someone could then try off-chain to hash your address and your move and all the different moves, trying to find the right hash. So throwing a salt in there would fix that. I'm just passing on from the chat.
Definitely, yeah. That would definitely be an improvement, because I know that salts are used to prevent like database lookups. So it's really powerful. I agree with that and appreciate the comment.
And you're getting into ZK territory too. I think maybe one of your next explorations could be go try the Circom starter kit and go play around with ZK and smart contract stuff, just because you can do more interesting things with circuits than just the hidden moves here.
I agree. but I wasn't really sure about what my next step should be. Are you suggesting the circumstarter kit?
Yeah. Here, I'll paste in we have this kind of like ETH dev tech tree in a Miro board, and buried in there are a bunch of resources. But at the top right of that, there's like a Circom starter kit and links to that kind of stuff. Also just keep building in ETH too, right? You could go down a rabbit hole in ETH and miss some other stuff, and Circom is like, that's like kind of next level cryptography stuff. Like once you know all your blockchain stuff, then start adding on the ZK stuff, right? But yeah, I don't know, that's a possible next step if you're interested. I feel like with the game stuff and the hiding in the hashes, it seems like ZK might be a next step.
Thank you for your comments.
Yeah. Who do we have next? I think Chijoke. I'd never say that right. I don't know if he's here. And then Danny, if Chijoke is not here. I don't know if he is. I think oh wait, unless Daniel is. Yeah.
Yeah, I think Chijoke just left like a couple seconds ago.
Shoot. Okay. So then Danny, shoot. Yeah, sorry. Maybe we went too long there. Yeah, I see CJ left. Shoot. Okay, well, maybe we'll grab him in a second if you hops back in. But Danny, if you want to go, you're up next.
Yeah, definitely. 1 second. Let me share my screen.
You cut your hair? What?
Yeah, I did. Absolutely. I was just trying to get a change for a bit. So where is this? Just trying to make sure it's just not one tab that I'm sharing instead of like the whole thing. So can you guys see this?
I think it's just, we see your 4 tabs. Yep.
Okay, great. So a little bit of context. This is a grant from the Unlock DAO, and this was supposed to be, there's an issue for an integration with the Ghost CMS for publishing and blogging. So it's been on there for a while, so I decided to take it on and build this out. It's still kind of in progress, so things may break, but I think it's ready for me to show it off. So I basically built out this API or interface to interact with the Ghost admin. So to get started, you basically need to sign a message. I need to hide this thing. It's all in my face. All right.
Yeah, we're not going to see your MetaMask, but you signed a thing in MetaMask just now, right?
Yeah. All right. So once you sign the message, you're going to click on Get Started to get to where you can create the integration. And this actually takes in a bunch of information, mainly your API key. So there's a question I have for that, but I'm just going to save that till the end. So right now, these are a bunch of tiers I created for testing. So I'm just going to go ahead and create a new one. I'm going to call this, I don't know. I'm just going to say XYZ, XXY, I guess. And I'm going to grab a bunch of lock addresses from here, paste that in. And so basically, the way the Ghost CMS works is you need to have like a monthly and a yearly subscription. So in order to simulate that, you needed to get like a way to lock monthly subscription and yearly. So that's why you have like 2 addresses, which kind of works with Unlock Protocol locks, which are like NFTs that you NFT factory contracts that you deploy on Ethereum. So put this in and you create a tier. It's going to ask you to sign a message, which is basically a combination of your the tier, the integration that you created and your Ethereum address. So when you sign that, it's going to create the tier. And what this does is it creates a tier on the Ghost blog. So normally you would actually deploy a Ghost blog. I don't know if anyone is familiar with the Ghost CMS, but if you have used that, you would like deploy your Ghost blog somewhere else. So this is actually the Ghost blog deployed on a different port. So on this admin, what you would do is you would want to create like a post. So a normal blog post that you want to create, you would come to the Ghost admin and you would like create a new post. So I'm just gonna title this, I don't know, scribe, and put some text. And so basically where the integration comes into play is here, the post access. So normally it would be public members only and paid members only. So how the Ghost paid memberships on your blog, you need to connect with Stripe. That's how the API is set up. So with this now, you can actually have like token gated memberships, and you can do that by selecting a specific tier. So these are all of the tiers I created for testing. Just gonna delete all of this and use the one I just created now, which is, you know, this XXY, lousy name. So gonna publish that, and it's out there. So gonna, oh, not here. Refresh this a bit. Okay, so we have this, but I'm going to like start from the top, sign out this account, and you know, get started. Typically, the user would come to your blog and actually sign up. So I'm gonna call this Luke Goldman xyz@gmail.com. Just a bunch of random stuff. And so all of this part is, you know, Web2 stuff, and I use a app for testing. So here, click confirm, sign up. And yeah, so this is how you sign up. And if you wanted to access this now, it would like tell you this post is for like subscribers on the XYZ tier. So I'm gonna like click on this, and when I try to subscribe, it now pops up the checkout modal from like the unlock protocol. So I use that for convenience. You know, you don't want to go reinventing the wheel when there's like an easy to use tool out there. So with this, you're gonna click on your MetaMask, sign a message.
Is it signing a message, or do you actually pay? Like, do you pay the $1 right here, and that goes through unlock protocol?
Absolutely. Yeah, this is actually, this goes,
using
this is directly to the creator using, like, this is just like an interface to allow easy checkout for people. You know, it goes directly to the person that deployed the lock. So oops, there's a problem. I think I've used this address before, and the way the integration is set up, it's supposed to be for one user and one email address. I don't think I have any free any address I have.
That's all good, man. I think we understand it. So you created a tier, like you use your own app to create a different tier, but then you use mostly the Ghost protocol to and unlock protocol to gate content. Is that right? So the Ghost protocol is the blogging stuff. You use unlock to gate the content. And what you did here was just show that you can like create your own tiers of things, and you were using your own kind of Scaffold-Eth smart contract kind of build to build that tier out. Is that right?
Yeah. So I guess what the thing is, there's no smart contract right now. This part is just a direct link between the lock that you deployed, which is like the NFT factory contract, and that is actually the token gate. So that's what I was thinking about. Like, I was actually trying to figure out an idea to build for a smart contract for this interface, but I really haven't been able to come up with anything. So this is where you like manage the integration, which is the creation of tiers, you can create. And I don't think the Ghost API has a way to delete tiers right now. So you can't actually delete them, but you can manage them. If someone were to subscribe from this blog interface, it would be like in the back end here, which is like an endpoint I'm still working on. So you would be able to see, if you were to go to your integrations and you like click into it, you would be able to still like click into this and see the members that are subscribed to this. So each of these are tiers, and you will be able to see the members and manage them in some way. If that makes sense.
Cool, man. I think we might have one or two more presenters. I don't know if we can fit in here. I saw that CJ came back. Chijoke, are you able to present? Nice presentation. Danny, keep building, man. Let's see, is CJ out there? Chijoke, and then maybe Shiv. Shiv, you want to show us something in the last 5 minutes? You got it, man. Oh, wait.
Yeah.
I think I see Chijoke. Maybe.
Yeah,
he was there.
yeah.
Oh, there he is.
Can you hear me?
Yep.
Yeah, I'm really sorry. I'm having issues with my connections, but I'm really excited to show off something if I can do that now.
Yeah. Sorry, Shiv. We'll get to Shiv.
Okay, so my build is a very simple scaffolded build that demonstrates how to use Gitcoin passport to gate an application, and it's TLDR. Gitcoin passport is a secure identity verification tool that enables us to showcase our identity without revealing personal information. It helps apps and organizations to verify our credentials without in a trusted and scalable way. And this is, let me just take you through the app. So when you hit the app detects your address and generates a message for you to sign, so that your passport score can be determined before you gain access to the dApp's functionalities. So this address does not have a valid Gitcoin score, passport score, so it's going to fail, or it should fail. So okay, let me refresh this. Oh, I'm really sorry about this.
I'd be checking my network. Oh, there it went. Did it something new
Okay,
happen?
yeah. So this is I just wanted to show what it looks like when an address doesn't have a valid score. You are directed to get a Gitcoin passport score, and then maybe come back to the app and try again. So this address cannot access the data. So let me use an address that has a valid Bitcoin passport score. Something the threshold for this the simple DAP is just 1. You just have to have a score greater than 1 to gain access to DAP, and you can mint this SVG NFT. So let me show you what the code looks like. Yeah, so this is the home page, the index page, and it houses the smile component and the gate. And when you get into the app, your score, it checks for a score, a valid score. If there's no score, you're directed to the gate where you would have to or the DApp goes and gets a message. It fetches a message for you to sign. In the repo, I made it in steps to show what goes on behind the scenes. We'll get a message. We'll get the user to sign the message. Then the message is verified, submitted before you can check the score, which is like the 5th step of this. I was trying to check the score directly earlier, and I figured out that you would need to submit the passport before you can check the score. So when a valid score is returned, we set the score. This is the Zoo stand store, the global store. So it just set your score globally. If it is invalid, set it to invalid where it shows you or directs you to where you can get a valid score. So the contract is basically just a very simple SVG contract to just showcase how I would get that functionality. But the gate is the main thing, and I made it as simple as I could just to show the process of implementing this gate.
It doesn't look like the score is actually on chain though, right? It looks like you send the address to Gitcoin and Gitcoin gives you a score back, and then based on that score, you're minting the NFT. It would be way cooler if you could get that score from them on chain and have the NFT represent the score that you got on chain, rather than having to do a little front end magic there at the end.
The thing is, the Scorer API is a centralized service, so I don't think it has an on-chain.
I don't think it needs to be. Yeah, it's not supposed to be. I don't think. I think it's for Sybil resistance off-chain. Yeah.
The Gitcoin server just serves the score, so it's just a front-end workaround actually. But I think it's a great solution for, preventing bots and, preventing Sybil attacks for applications that require that. And it also ensures you have unique users, because I don't think you can use an address or different address to get credentials for the same social media, if that's clear. Like you would have to be a unique user to actually have a valid score or a high score. So you could actually use this to make sure you are getting unique users and prevent bots and malicious actors.
Yep. Yeah, I think it helps prevent Sybil resistance, or gives you Sybil resistance, and that's important for things like quadratic voting and a lot of those things that require kind of like one human, one vote and stuff like that. Okay, let's hand it off to Shiv and then maybe Bert if Bert's around, and then we got to call it. We're way over time. Sorry for all the folks that thank you for hanging out extra long. If you're out there, Shiv, do you want to show off what you've been working on?
Yeah.
Cool passport NFT Chijoke. Nice build.
Yeah, thank you. I'm trying to share.
Is my screen visible?
Yep, I see Zach. Nice.
Yeah, it's a very small utility app for Scaffold-Eth 2. So what you can do is, like in Scaffold-Eth 2, we have these different, like you need to maintain a structure to get your custom hooks working. So you need to put the contact in particular order to get all the auto completion with the TypeScript. So what I've done is I have built a small utility app where you can just copy the existing object which you have, and let's suppose you have an external contact which you didn't generate through SC2. So you can just merge it with here. Let's suppose I call the new contact as my contract, and for demo, let's say its address is this, and let's suppose we have deployed it on chain ID file, and then you need to put the ABI of the new contract. Let me copy it for demo purposes, and then once you submit it, it will give you the whole object. So you can just copy paste the whole thing in your Scaffold-Eth to this contacts file, and you will get all the auto completion. Also, you can fetch the, if you have already verified the contact on Etherscan, so you can easily fetch it through Etherscan. So let's suppose, let me grab the DI contact address. Yeah, so it fetched the ABI and it aligned it in the proper way. So you can just copy this whole thing. And put it here, and then you can just use all the hooks, let's suppose. Yes, full contact hook, and you will get all the auto completions. Yeah, so it suggested that. And then you can write something. Yeah, that's it. So basically, if you need to, if you have an contact which is deployed or which is already deployed, so you can just come to ext-contracts.vercel.app, and you can just get the object which you need to get all the auto completion. Yeah.
I almost want that running underneath the abstractions and just kind of merging it for me, right? But just to recap there, basically we have a certain format that we use for our deployed contracts and tracking those artifacts, and they can contain all sorts of different deployments for all sorts of different networks, and sometimes you have them in scattered places or you want to bring in an external resource. And so you made a quick little utility that kind of merges those deployments into a single formatted piece. Is that right?
Yeah.
Nice. Cool, man. That seems like that would be handy. Seems like you guys will use that for sure. Awesome, man. Okay, here we go. I think last one is Bert. If Bert is still out there, I think we accidentally skipped Bert last time, so I don't know. Bert, if you're out there, give us the last demo for the day.
Can you hear me?
Yep.
Okay, I'm very unprepared, and I think that it's gonna not work. But I just gonna give like the introduction, and then maybe I can get some feedback. But yeah, let me just do that. Okay, I'm gonna share screen and entire. Interesting. Whiteboard desktop 1. So if I want to share the whole screen, how do I do that? I don't see.
Sometimes it's like a different tab where you have selected like, different windows, and then there's another tab for whole screen. I can't remember.
I don't see it. I just see like a
Oh yeah. In the top left, I have like whole desktop to share, and then I have, I don't know, it might be different for everyone.
Okay, let me.
Oh, there we go. We're good. We got a desktop. Nice.
Okay. Can
Okay.
can you see what
Yep,
can you
we've
see
got
now?
code.
Good.
Yep.
Okay. Good. Good. Okay. So the front end is running right now, and this is just a data community in research. So just suppose that you want to you are a researcher, and then you have some data that you would like to publish and open source it, so you can come here and publish it. And then the idea is just to have data so other people can use it. So in this example, I can just come and upload my data. Suppose that I would like to suppose like I have some data for a sleeping data set, and then you just post that. You can do some tags by comma separated, and you can add a price, or you can make it made available for free. So in this case, I'm just gonna put 1, and then here it's a confirmation, and then you confirm. Did you check the data that is correct? It's gonna ask for confirmation. You confirm, and then this is just the metadata. The next step is adding your data set. We want to wait for it to just come back and finish the transaction. But yeah, the next step is to choose your data. In this case, I'm just gonna select a txt file. I do that, and then after that, I can upload it to my to this data set, and then at the end, I should be able to go and retrieve it from this part. So let's see if that works. So let me just refresh that and just make sure that I got it. So so it's gonna get it, and now I don't know if I get it. But I think that it will be somewhere here. Actually, it will be the last one. Will be this one is sleeping data. So it's here, and now you can mint it. So now, if let's suppose that you are another user, you can come and mint it, and then now that you mint it, you can get access into the data and then download it. For some reason, the get access, I am using lead protocol to do this, and it's not working really well with Next.js, the lead protocol, but it's just funny that it works with regular HTML. So I just need to find a way to make it work with Next.js. But that will be my next step, just to make it work with Next.js. And then how it works is that in my contract, I have a create data set, and it's just to create. And then in my contract, I have a mint function to mint the data set. And then I am using this number of tokens to get the data set tokens as a get it token. And then here in my details, I check. I have some conditions using the lead protocol. Using this lead protocol, I have some conditions here. So this is to encrypt the file, so that if you don't have the token, you will most likely get a decrypted file, an encrypted file. This is how we initialize the lead protocol, and here when we decrypt the file, we're gonna pass the access controls. In this case, we pass the contract address, we pass the contract type, the method that we want to call in our contract, and a user address. And then how many, in this case, how many tokens? In this case, I just pass in 0 so that anyone can get it. But here you should be able, the author or the creator of the dataset tokens should be able to choose how many tokens he needs in order for other people or other users to have access into your account. And then if it passes this access control, it will get your auth sign, and then it will just pass all of this to LED protocol. And then if it passes all of that, then it will give you like an encrypted, a decryption symmetric key to decrypt your file, and at the end it will set the URL so that you can get the datasets decrypted, and then after that you can use the dataset to do your research or your stuff. But yeah, that's all I have for now. But yeah, you should be able to like to get access. If you don't have it, you haven't minted, you should be able to mint it. Then after that, I would like to combine these two so that we can, when you say get access, it does both. It just checks that you have the number of tokens required, and then it downloads the file to your computer, and then after that you can just go ahead and use the dataset tokens.
And there's a lot of stuff going on underneath that abstraction, like that really nice interface of like, oh, hey, here's this data set that I want. I'm willing to pay for it. Pops up my wallet. I pay it. And then I get access. There's a lot going on underneath there. And it looks like this is like also like a really good example of lit protocol, or just a good example of what you can do with lit protocol. But it looks like what you're doing is you're taking a data set, you're putting it into IPFS, you're kind of tagging it, and then you're using lit protocol to say, you know, if this person has this specific ERC 1155, then give them access. And it does that check like to do the decryption. So you take your file, you put it into IPFS, or maybe it gets encrypted on lit protocol, and then someone has to have that specific 1155 for them to be able to decrypt it out of lit protocol. Is that right?
Yeah.
That's cool.
We passed that. We passed those conditions to lit protocol.
At first, I thought my feedback was going to be you were storing too much stuff on chain, but it seems like you're probably not storing very much stuff on chain, just the IPFS records.
Yes,
and
it's the
some of
CID.
those requirements. Yeah.
Cool.
Cool.
Then, yeah. So that's all I have. But yeah, the next step is just to combine these two, and then
Right. It's just one click and it just happens. Yep. Totally.
Yeah. And then if you don't have the requirements, it's on like save an alert, or like an alert on the notification you don't have the number of tokens required, and then just show the number of tokens required, because when you upload it, you can select the number of tokens, how many you require for people to get access into your data set.
This is it would be cool to just see this as like a forkable example that people could use. It might be hard to get, you know, like decentralized science going and data sets available for sale, but maybe someone could use this same exact model for selling poetry online or something like that, right? There's more that you could do, but I don't know. I think that like, I think it might be hard to get some data sets and some sciences to be like, yeah, let's put this here in Polygon and put money on it. But I think maybe if we could find a smaller use case and fork this and use this for a smaller use case, that could be really exciting. But also it would be great if, you know, medical industry was using stuff like this because of the encryption layers and the auth gating. But this is a really good build. Good job. Keep going, Bert. Keep building.
Thank you.
Awesome. Okay. I think that's Bowtie Friday. I think we did it. Happy Bowtie Friday, everybody. Thanks for coming by. See y'all in a couple more Fridays. Later.